Hi, welcome to our first video for 5.4 graphing and modeling with these two sinusoidal functions. Okay, I'm just going to write that out here. So they're both sinusoidal functions, even though this one says cos here instead of sine. The reason why they're sinusoidal is because they follow the nice sine curve. Whether they've been transformed or not, they still kind of follow that. Now, why do we want to know how to model using these functions? Well, there's a lot of real life scenarios that kind of follow this pattern, that sinusoidal function pattern. Okay, so it says here, in order to model a real world situation using a sine or cosine function, you must analyze the situation and then transform the amplitude, period, vertical shift, and phase shift accordingly. For example, tides in the ocean could be modeled using a sine function with a period of about 12 hours. So you can kind of see in this photograph, we can see low tide, people are walking, underneath this little rock basically here. And then at high tide, there's nobody here and the water level is almost all the way up. So the tides change every 12 hours and their position or their height could be modeled using a sinusoidal function. So how do we do this? Well, we basically need to figure out what the amplitude would be, the period, and if there's a vertical shift that's needed and a phase shift. And then we have our equation. So that's what we're going to spend the next little bit doing. So here's our first example. It says determine the characteristics of a sinusoidal function from an equation. So it says an engineer uses the function y equals 3 cos times 2x minus 5 plus 4 to model the vertical position, so that's kind of like a height, of a rod in a machine X seconds after the machine is started. So part A, what are the amplitude, period, phase shift, and vertical shift of the position function? So that's pretty easy. We can just compare this to our general form. And then we can get our parameters and we can answer all those things. So we're just going to do a solution right off to the side here for now. So A is equal to 3. Therefore, I got that right here from the equation. Therefore, the amplitude equals 3. The period, that's going to be equal to 360 over K. K is 2. So we're going to get 180 degrees for that. Or not even degrees, just 180. And our phase shift, so that's going to be D, and it's equal to 5. Okay, so we can say 5 units, or we'll say shift 5 units to the right. And lastly, the vertical shift. So that is our value for C at the end. C is 4. So shift up 4 units. It also means my middle line is going to be at 4, right, when I go to do the graph. Okay, part B, what are the lowest and highest vertical positions that the rod reaches? So what's my maximum value? Well, my maximum is always equal to the center line on the graph plus the amplitude. Okay. So in other words, it's going to be C plus A. So my center line is at 4, and the amplitude is 3. So my maximum value is going to be 7. The minimum value is the center line minus the amplitude. So that'll be C minus A So that'll be 4 minus 3, that'll be 1. Okay, part C, it says, use technology to graph the function. Check your answers in part B using the graph. Okay, so our function is y equals 3 times cos. K is 2. We've got another bracket, x minus 5. Close up the brackets, plus 4. Make sure we're in degrees, and we are, plus 4. There we go. So it's a little hard to see. I'm just going to stretch out the x-axis a bit. Okay, so my max value, we can see that has a y value of 7, and the minimum has a y value of 1. So that definitely checks out what we had said back here for our max and min. Okay, and again, if you want to compare like this to the graph up here, my center line was at 4, and you can see that if I graph the line y equals 4, okay, that shows my nice center line that cuts through the middle of the graph. Okay, so when I do this calculation here, the center line is at 4, and then I know the amplitude is 3, so if I just add 3, I get my maximum value, which would have to be at 7. And you can see there's exactly 3 squares till we get to the top from the center line. And same thing with the minimum, we just move 3 down. Okay, so that's part C. I'll just kind of do a quick sketch. So we had 1 and we had 7, and then we were at 4 for the center line. I'll just write max and min, and then I'll write C. And in between there is always the amplitude. Okay, part D, state the domain and range of the original cosine function and the transformed function. So for y equals cos x, the domain, we can say x is an element of R. Okay, there's no restrictions. Okay, even looking at a cosine graph, there's no restrictions for x. And the range, well, remember cosine goes from -1 to 1. It's always within there. So we'll say y is an element of R. And it goes from -1. So y is greater than or equal to -1 and less than or equal to +1. And then for our transformed one, so y equals 3 cos 2 x minus 5 plus 4. So this domain is also x as an element of R, no restrictions. The range, though, is different. So the range is going to be between R max and min values, which is 1 and 7. So we'll say y is an element of R, y is greater than or equal to 1, less than or equal to +7. Okay, I hope you found this helpful. That's our first example. I will see you guys in the next video.